In this video, I'd like to do a quick review of the Houdini interface. Now, I do expect that you guys are already pretty familiar with the basics of the Houdini interface, but I'd like to have this video as a reference point both for you and for me, so that we can tell if there are any gaps in foundational knowledge that need to be addressed before we get into the more complicated Python stuff. So really quickly, the Houdini interface is divided up into panes. You have the viewport here, you have the network editor down here, and you have the parameter pane here. The viewport is where you actually see the effect that you're working on, or the results of whatever you've built in the network editor. You can left click and drag to rotate the camera. You can middle click and drag to pan the camera, and right click and drag to zoom in and out. You can also turn the scroll wheel on your mouse to sort of zoom in and out. Now, every effect that you build in Houdini is made up of nodes, and those nodes are what you set up in the network editor down here. You can create a node by using the tab menu. So if you put your cursor into the network editor and you hit tab, you get access to the tab menu. You can either scroll through and find the node type that you want in here, or if you already know what type of node that you want, you can just start typing the name of it. So in this case, I want a geometry node, which you can find here under geometry. So if we just start typing GEO, geometry, you can either click geometry here, or you can just hit enter if it's highlighted, which I just hit enter, and then hit enter again to put it down, or you can click to put it back down. Now you use the same controls for moving the network editor as you do in the viewport. So if you middle click and drag, you can move it around, or you can scroll the mouse wheel to zoom in and out, or right click and drag to zoom in and out. So every node in Houdini has a name, and you can change that name by clicking in this little name here. So where it says Geo1, I can change that to something like particles or whatever. And you'll notice that when I change this, it actually updates here. So I can either change the name up here or down here. So if I change this to grid, you can see that it changes there. Now also notice that I can drag boxes around nodes to select them, or I can click on them to select them. And when I select a node, it actually updates the parameter pane by default. So if I were to create another type of node, say a null, so hit tab and type null, and put it down, you can see that there are different parameters here. Grid has a material tab there. And you can also see that it shows me the type of the node here, and the name also updates when I select the other node. So I'll just delete this null real quick. And let's learn about contexts. So in Houdini, it's divided up into a bunch of different sections, each of which is called a context. So if you look through the tab menu, where we're at right now, and you look at all the different types of nodes, you might notice that all these nodes seem to deal with objects in some way. And none of them seem to really get into the nitty-gritty details of actually generating or manipulating geometry or particles or RBDs or whatever. And if you notice this, you would be right, because we're actually in the object context right now. And we can tell that we're in the object context right now by looking at this little pull-down menu here. Notice that it says OBJ there. That means that we're in the object level context. If we click on this menu, you can see that a bunch of different contexts in Houdini, although there are other ones that are not displayed here. So we won't actually be using any of these contexts in this class for the sake of being concise, but just know that they're all out there. So I can just click somewhere else to get rid of that menu. And the other thing to note about this pull-down menu is that it's actually representing a path to a node. So every node in Houdini has an internal path. So what you do is you start at slash, and then in this case we're in OBJ, because you can see that there. And this node would be grid, because it's called grid. And if you want to see this path a little bit more easily, what you can do is you can right click on this pull down menu, and where it says edit path as text, you can click on that. You can see it says slash OBJ. So slash is like the root, and that contains everything. And then OBJ is the object level. And then if I double click on grid, that'll take me inside of grid, and you can see that it updates to have grid in that path. Okay, so now we're inside this node, and what does that mean? Well, in Houdini, geometry nodes are what's known as containers, and containers contain other types of nodes and often other contexts. In this case, we're actually in another context now, which is called the surface level context. In Houdini, there's a sort of slang language that goes along with it. So for in the surface level context, we're dealing with surface operators, so we call them SOPs, S-O-P. So the way that you would use this language is you would say, this node is a file SOP, because it's a file surface operator. And if you're wondering what the path of this node is, it would be /obj /grid /file1. Note that I can't go into this node because it's not a container, so if I do /file1 here, it doesn't actually take it. So what does this look like in the more graphical view when it's not this path here? Well, if I right click on this again, you can see that it goes back to edit path graphically, and it goes here. And you can still see the same things. It's still obj grid. It's just a little bit more graphical. You can tell what kind of node you're in. This little icon means it's a geometry node. And maybe it's a little bit nicer. The other nice thing about a graphical path is that you can instantly jump to any part of the path by just clicking on it. So if I wanted to go back up to obj level, I can just click there. It just takes me there. And if I double click on grid again to go inside, now I'm back inside there. And this will work no matter how far you are in this path. You can click anywhere on there and instantly jump to that level, which is kind of nice because if you're editing as text, you actually have to select the part that you don't want and delete it, and then hit enter, and then it'll take you there. Whereas if you edit path graphically, you just click the button and you're there. Okay, so let's rename this grid node to something like explosions, because explosions are fun. And then let's go ahead and create the demo setup. Now, this demo setup is something that I'm going to be using for a lot of demonstrations throughout the course, so it might not be a bad idea to follow along and create it yourself. So if I double click to go inside here, I do not need a file SOP, so let's just go ahead and delete the file SOP. Okay, so the first thing that we're going to talk about is how to set up a simple particle sim. So let's just create a source for it. Let's just start with a grid. So if I hit tab while my cursor is in the network editor and type grid, there it is, or I can find it under primitive. And primitive is where you find all of your basic shapes like boxes and spheres, and grid is right there. So if we grab that and we put it down, you'll notice that we have a grid here. It looks like a box, but if I want to see it as a grid, I can hit the W key, again while my cursor is in the viewport, because remember about that context sensitivity that we get in Houdini. So if I hit the W key, it takes me to wireframe mode. And then I can see it's a grid. Now, Houdini's homing plane is kind of making it hard to see the grid, because it's another grid overlaid on top of my grid. So let's just go ahead and get rid of that. You can do that by clicking this little button up here. And now it's just the grid that this node is creating, which makes it pretty easy to see. We can add a little bit more detail by changing rows and columns here in the parameter pane, so let's just do that real fast. Let's make it 15 by 15, maybe. Okay. And now let's set up the basic particle sim. So there are multiple ways of creating particle sims in Houdini, but I think that the simplest and easiest to understand is to just use a popnet. So if we make sure that our cursor is in the network editor and hit tab and start typing pop network, can grab that, put it down, and then now is probably a good time to talk about inputs and outputs on nodes. So every node in Houdini has what's called an input and what's called an output. Well, most nodes have inputs. These little connectors on top here, you'll notice that as my mouse hovers over them, they kind of glow. These are what's called inputs, and the popnet has 4 of them. Inputs are where you accept geometry from some other node. And at the bottom of the node, you'll notice that there's only one output, and all nodes and SOPs only have one output. So what I can do if I want this popnet to accept geometry from this grid is I can click on the output of the grid and then click on the input of the popnet. And then what Houdini will do is it will say, okay, so for this node I'm going to create a grid. And then it goes down to the popnet because that's the next node that it's wired into. And it'll say, okay, so for this input I'm going to be receiving the geometry the grid created. Now you'll notice that I have a warning here. That's what this little yellow outline means. So the way that I can see that warning is by middle mouse and holding on this popnet. You'll notice that I get a whole bunch of information here, like how many points are in the geometry at this point, what the size of it is. This is all 0 because there are no actual particles at this point, but it'll tell you what your attributes are, which we'll be getting into attributes a little bit more later. And down here at the bottom, it tells you what the warning is. Now, this warning is actually not that helpful, but what it means is that there's no source. So this popnet is actually a container node, just like the geometry was. So if I double click on it, I can go inside of it, and you'll notice that my path updates so that I now am at /obj/explosion/popnet1. And if you want to see this for yourself, again, you can edit path as text. And you can see that it's indeed where we are, and what's being displayed is the contents of the node at this path. So I'm going to right click on this again and say edit path graphically, and we'll go back. So the way to get rid of that warning up there and to actually get some particles is we need to create a source pop. Aha, you notice that I said pop. That's because we're in particle operators now, and in Houdini slang that's called a pop. Which kind of makes sense for particles, I guess, because they kind of pop. Anyway. So to create a source node, we make sure that our cursor is in the network editor. We hit tab and start typing source. And then notice that it's errored. And that's what it means when these big red lines are cutting through the node. To see errors, we do the same thing that we do to see warnings. We middle click and hold. And in this case, it's saying cannot obtain the geometry of the specified SOP. So what it's saying is that it's trying to get the geometry from somewhere. But in this case, it's saying that I want to get the geometry from this SOP field, or what's specified there. So I can just hit this button. It brings up this choose operator menu. And then I can go to /obj/explosions /explosions, and then I can pick whatever I want to have emit my particles. So maybe I could say grid 1. And now if I go down here to my play bar, I can hit play. You can see that it's creating particles on my grid. If I zoom in, hit play, there's the particles. Now if I do it this way, you'll notice that I'm specifying an absolute path here. So it's not actually using the input to the popnet. So if I click on explosions here to come out of the popnet, I can unwire these by just clicking on the input and then clicking somewhere else and it unwires. And you'll notice that the warning doesn't come back. And I can even hit the up arrow to play and it's still working. That's because I specified the path manually. So if we just wire these back together and then double click to dive inside, instead of specifying the path manually, what we can do to make things a little bit more visual and maybe a little bit easier to read is we can change this geometry source here. So instead of it says use parameter values, which is basically telling it to use this parameter, we can click on this drop down menu and say use first context geometry, which is kind of a strange way of saying I want to just use the first input of my parent popnet. And now notice that it does the same thing. But the difference is that if we click on explosions again to come out of the popnet, if I unwire this and go back to the first frame, you notice if I hit play now, no particles. And that's because there's no longer an input, so it doesn't know what to do. So if we go back to the first frame, let's just wire these, wire these back together and dive inside. Now you might be thinking, well, it seems like if I leave this on use parameter values and I just specified the SOP path by hand, you might be thinking that that's better because then it doesn't error. And then or it's not as easy to make it error, because I can disconnect it and it still works, because it still knows where to find it. And here I'd like to introduce a concept that might seem a bit strange, and that is that errors are actually good things. And really, it's, especially as we start going into Python, it's really a good idea to get into that mindset as much as you can, where it's actually good that you're seeing an error. If the setup isn't behaving in the way that you expect and you don't have an error message, it can be actually really difficult to determine where the error actually lies. So I think that if we change this to use first context geometry, we come back out and we disconnect this input. Now we don't get an error from here, but if we play, there's no particles. And so we might be like, where's the problem? And if we double click inside, now there's an error and it says cannot obtain the geometry that specified SOP. And because of experience, we know what that means. We know there's a problem with the source up here. And so we come back out and we're like, oh, yeah, okay, so this isn't connected, so that's the problem. And then we just hook them back in and everything's good. Whereas if I go back inside and I change it back to here, use parameter values, and then maybe in some other part of my setup, I have something that relies on this input being connected. So I'm using some expression that uses that input to determine what the emitter is. Then when I disconnect it, it still works and I get particles, but the particles won't move in the way that I'm expecting. And then when I come back in here, there's no error to tell me what's actually going on. And especially if I didn't actually make this setup and I am picking it up from someone else, I may not know that there's nodes down here that are using that op input. And so when I come back out here, I don't necessarily know that this is supposed to be connected, even though it somehow accidentally got unconnected. Now, this example is a bit cheesy, but I hope it demonstrates a bit that it can actually be nice to see the red lines, even though you might at first instinct be like, I want to get rid of all the red lines. It's nice to see them because it actually shows you where problems are in your setup. And that's why side effects provides them, and that's why Houdini actually gives you errors. And when we get into Python and we start generating errors of our own, and on purpose, to show people who are using our setups what's wrong, this is something to keep in mind. Okay, so let's just change this back to use first context geometry. Now, I have my particles, but they don't move. So let's add a simple force in here. So if I put my cursor in the network editor and I hit tab again, I can start typing force. And this allows me to create a force pop. And again, I have inputs on the top and outputs on the bottom. And in particles, it works a little bit differently from in SOPs, because in SOPs it's actually generating the geometry when it hits each step. But in particles, what it actually does is it generates data that it then uses to sim at each step. So when I hook these two together, I'm not actually saying pass the geometry from the source pop into the force pop. What I'm saying is, okay, so I need it to have a source with these values, and then I need to have a force with these values, and then Houdini will do the sim using the values that I've specified. I do still need to set the display flag though to show it where it's going to stop. So if I do a force just by default and I hit play, nothing happens, it still just stays on the points. So let's just, and that's because there's no direction to the force. So I eventually want this to be gravity, so let's make the direction just -1 in y. And now if I hit play, after my particles are generated, they slowly fall down. If we want to make it physically accurate gravity, we can just change scale here to 9.8066, which is physically accurate gravity. And it'll still go down because you'll notice the direction is -1. Now you could just leave the scale at 1 and put -9.8066 here, and maybe that's clearer for some people. I think it's easier to see when scale is something and this is just a direction, but I think that's a matter of personal preference. So now if I hit play, they respond, and then they fall with physically accurate gravity. Now when they play, they keep falling and falling and falling and falling and falling and falling forever. That's a bit annoying. So let's just go ahead and add a collision. So if I put my cursor into the network editor, let's just go ahead and hit tab again, and then we can start typing collision, C-O-L-L-I, there it is. Just put it down. Again, wire the input into the output there. And then we set the display flag on collision. And notice that nothing happens. And that's because I haven't actually told it to collide against anything yet. It's just a collision data that I've added. So if I go to geometry source here, you can see that this is a similar interface to what we had on the source pop. So I could change this to use second context geometry, which is the second input of the parent popnet, which is popnet 1. This is still not good enough though, because there's actually nothing wired into the second input. So let's just wire something into the second input of the popnet. Let's say another grid. So if I put my cursor into the network editor and I hit tab and start typing grid, we can put down a grid. And now if we wire it in, you should see your grid appear over your other grid in blue. So if I select grid 2 and I put my cursor in the viewport and hit enter to enter object selection mode, and then I just use the handle to push it down and maybe scale it out a bit. Let's make it pretty big so that there's plenty of places for the particles to hit. And then I'll just hit escape again to go back to camera movement mode so I can move without using any modifier keys. Now if we double click on the popnet to go back inside, and we hit play, now the particles just fall and die when they hit that grid. This is a little better, but I'd like them to actually hit and bounce. So if we do that, if we want that, then we can select our collision node, go up here to behavior, and you'll notice that it says behavior is die on collision, which is indeed what we're seeing. So if we pull this down, we can see a whole bunch of different things. And what we want is bounce on collision. And if I hit play, you can see that it bounces. And they just continuously bounce. So if we want them to behave a little bit more realistically, so they don't just sit there and bounce endlessly like ping pong balls, we can change this gain normal. And basically what this gain normal means is every time it hits, for the normal of the velocity will be multiplied by this number along the particle's normal. So I can make this something like 0.4. And then make gain tangent the same number. And now if we hit play, it bounces and then comes to rest. So the final thing that we'll cover in our review of Houdini is attributes. So if we come back up out of the popnet by clicking on this explosions button here, let's just create an attribute real fast and then I'll explain how it works. So the easiest way to create an attribute in Houdini is using the attrib create node. So if we just pull this grid up a little bit, hit tab and type attrib create. And then I'm just going to click on the wire to put it down, and it'll just automatically wire it inside that wire. So let's just set name here to really whatever you want. I'm going to call mine Blorg, because Blorg is cool. Let's just leave the rest of this interface alone for now. So what did this do? Well, if I set my display flag on this attrib create, and then I middle mouse and hold on it, you'll notice that where it says 2 point attributes here, it used to be 1. So if I middle mouse and hold on grid 1, you'll see there's only a 1 point attribute until it gets to this attrib create where it's creating an attribute called Blorg. Now Blorg is a point attribute, and what that means is that it can have a different value for every point on the geometry. If I wanted to make it a primitive attribute, I could change the class to primitive. And since grid is made out of polygons, each of those polygons is a primitive, and so that means that this attribute can have a different value for each primitive. And if I middle mouse and click, you can see that it goes into a different category in here. The other types of classes that you can have are vertex and detail. Vertex is special for polygon type geometry, and it just means that it'll be on a per vertex basis. So inside this one point here, if I turn on point displays with the numbers, you can see that there's only one point there, but there's actually one vertex for each polygon connected to that point. And that's the way that Houdini just thinks about vertices and points. So in this case, there would actually be 1, 2, 3, 4 vertices contained inside this point. And you could have a different value in the blorg attribute for each one of those vertices. So I'm just going to turn off point display and zoom back out. And let's just make our class back to point. So how do we actually set these attributes? Well, you do it using this value here. So I could use an expression to set it to, say, a different random number for each point. And the way that I would do that is I would use the rand expression, R-A-N-D. So if you don't remember the rand expression, essentially where it says float value here, it's expecting you to give it what's called a seed. And a seed is essentially just some number that tells you what your position in the random function is. So if I gave it 10, I would get one random number, and if I gave it 11, I would get a completely different random number. And this generates random numbers between 0 and 1. So if I want to have a different random number for every point, I would just give it as the seed the current point number. So if I delete 11 here, I can access the current point number by saying $PT. So it's like the first and last letters of the word point in capital letters. Now if I hit enter, you actually can't see anything. But there is a different random number on each point. And it'd be kind of nice to be able to actually confirm this. So let's talk about how to visualize attributes. So if we want to visualize this attribute in Houdini, we need to create what's called a custom attribute visualization, which is a mouthful, but it's actually pretty simple. So if we put our cursor in the viewport and we hit the D key, D for display, under this markers tab, we can create these custom visualizations. Now the way this works is there are 3 different types of visualizations you can create. The first is generic, and generic attribute visualizations are not something we'll be using in this class. They're basically there so that you can visualize custom changes that you've made to the viewport, which is a bit beyond the scope of this class. The second type of visualization is what's called a text visualization. So if you click on where it says 1.2 there, it brings up this little dialog that lets you set attributes, or lets you set settings for the visualization. So we can set the name, which is just the internal name of the visualization. It doesn't really matter what it is. We can set label, which is what's displayed down here. And then we can set attribute, which is the name of the attribute that we want to visualize. So I could say here, I could say blorg. And then for label, I could say blorg. And then for attribute, I could also say blorg. And now if I hit apply, or even if I hit accept, still nothing happens, and that's because I have to click this little check box here. If I turn that on, now it displays as text the value of the blorg attribute for every point. If I zoom in, now you can see that indeed there's a different random number on every point. And then I can check that off. So this blorg attribute is actually not that useful for controlling the popnet. In order to control the popnet, we need to create, let's say, velocity. And then velocity will be inherited by our particles, and I'll show you how that works after we create the velocity attribute. So if we want to create velocity, it's a great time to show you guys the other way of creating attributes in SOPs, or at least another way. So if we just move this off to the side, I'm going to create a point SOP and put it down, and then I'm just going to wire the first input into the grid, and then we'll just click on the wire here and move it over to the point SOP. So what you want is to have the grid wired into the first input of the point SOP, and then the point SOP wired into the first input of the POPNet. And then I can click into this little blue box to display. Now the point SOP is a node that is specifically intended to loop over points, and it allows you to perform expressions on each point. So this allows you to set things like the color of the point, the normal, you can set UV coordinates on it. But what we want is velocity, which is actually a particle attribute. So if we go over here to particle and come about halfway down, you can see that there's this keep velocity pull down. Just click on it and change it to add velocity. And add velocity just means that we want to set the velocity attribute and then create it if it doesn't already exist, which in this case it doesn't. So this $VX, $VY, $VZ, this is basically telling the point SOP to access the value of the velocity attribute, as it already is. Which in this case it doesn't actually exist, so they're all 0. We don't actually want to use these, so let's just right click on velocity and say delete channels. You'll notice that makes it 0, 0, 0. And then we can just set the Y component of the velocity to, say, 5. So you'll notice that again we can't see anything change in the viewport when we do this, and that's because we're just changing the velocity and nothing's moving yet, so we can't actually tell what it's doing. But we can create another type of visualization for it. So if we put our cursor back in the viewport and we hit the D key again to bring up display options, we can create another visualization. And in this case we want a vector visualization because velocity is a vector. So if we go over here to this little button that kind of looks like a dot with a line coming out of it, that's supposed to be a point with a vector sticking out, and we click on that, we get the same dialog that we got when we created a text visualization. But in this case it's actually going to be a vector. So we can change the name, let's say V, and label V, attribute V. You'll notice that I'm kind of in the habit of setting all these things to the same thing. That's because what I want to know when I'm turning it on and off is what attribute it actually is. So I usually just set these all to the same thing because I like to have it display what attribute it actually is. You could make these different things if you think it's easier for you to see, but I think it's easiest just to see what attribute of visualizing. So if I hit accept, you'll notice that it changes to V over here. And if I turn it on, now I see all these little lines sticking up. And that's because it's showing me my velocity attribute. So I'll just hit the X to get rid of that. So if we want to see this in action, if we just change the X component of the velocity to say 1, you can see that it moves on X. Let's even change it to like 3. You can see that now the velocity is pointing off on the X-axis. Let's just set it back to 0. Now the interesting thing about the way that Houdini is set up is that the POPNet will actually automatically pick up this velocity attribute. So we can use this to control what the POPNet's doing before we actually even get into the particles. So if we display the POPNet, let's just see what it does right off the bat. If we hit play, you'll notice that it now is launching the particles up above the source. And that's because that's what we set the velocity to. So even while it's still playing, we can go back here to the point SOP, and we could put the 3 back into the X component. And now you can see that it's kind of launching the particles to the side. It's a bit hard to see. Let's change it to like 10. There we go. So let's even just turn it so that you can see the axis that it's moving on, and then play it. Now you can see that the particles are sort of being launched off to the side. That's too much. So if we go back to the point stop, I can just change it back to 3. Or if I'm having a really hard time figuring out what this value should be, I can just scroll it up and down. Launch, don't launch. Okay, so that's pretty much it for attributes. We'll be getting into attributes a lot more later in the course. The last thing I'd like to do to this setup before we conclude the review is to just make sure that this grid just sort of spits off particles and then stops. And we'll be doing that because of how the demonstrations later in the course will work. So if we go back inside the PopNet by double clicking on it, and then go to our source, we want to just emit one particle for every point on the grid at the beginning, and that's it. So if we go to birth, we can control that using this impulse activation and constant activation. So constant activation and birth rate is essentially, it's the same thing as the impulse. It's just that this is in seconds and this is in frames. So with constant birth rate, it will not actually change the total number of particles emitted per second if you change the frame rate. Whereas with impulse birth rate, it will change it every time it will emit particles every time it actually cooks these nodes. So the interesting thing about impulse birth rate is that if you come back up out of the PopNet and you set this oversampling, if you set this to 2, I can even show you. If we set impulse birth rate to, let's say 10, and then just set constant birth rate to 0, so now it emits like this. If we go to the PopNet and we set oversampling to 2, it's kind of hard to see. Let's even set it to like 10. You can see that we get a lot more particles. And that's because every time it actually cooks, including for the oversamples, it's actually emitting 10 particles. So this may or may not be what we want, but in this case it doesn't matter because we're only going to be emitting on one frame. So if I come back up out of the PopNet, let's just go ahead and set oversampling back to 1. Double click to dive back in. Let's just set impulse birth rate to be the number of points in the source geometry, and we can do that by highlighting it and hitting $NPT for a number of points. And that means that every time this source node cooks, it's going to emit a number of particles equal to the number of points in the geometry. And now I only want it to do that on the first frame, because I only want it to happen once. I want it to spit off all the particles, and that's it. And the way I can do that is with this activation. So the way the activation works is if it's set to 1, it will emit. If it's set to 0, it does not emit. If I even play, you can see it doesn't emit. So what I can do is use another expression here to control that. So if I say $F, which is the way that you access the current frame number, and then I use a double equals sign, which is the way of testing for whether or not the values on either side of it are equal. And I say $F start, which is Houdini's way of saying the first frame. I hit enter. And now if I hit play, you can see that it just emits particles once. And this will be useful later on when we modify this setup to make tools out of it. And actually, if we come back up here to explosions, I'd just like to make this velocity go straight up again. And then we can turn off our velocity visualization. Again, you hit the D key with your cursor in the viewport, and turn off this check mark. And hit the D key again. So this concludes our quick Houdini interface review. Now, I went through a lot of material really quickly, and I didn't really stop to explain in detail most of it. And again, that's because I'm hoping that you guys are already familiar with most of the material that I covered in this, except for possibly the stuff about attributes. I promise that in future videos, I'll be going through things a lot more slowly and methodically, and I'll try to explain in a lot more detail how things work and what things are doing. So please let me know if you guys didn't understand anything, so that we can address any foundational issues before we get into more complex things that build on this general knowledge.